Hello, this is Mr. Huber. In this lesson, we're going to learn about the equations of parallel and perpendicular lines. Let's first start with parallel lines. Parallel lines are lines in the same coordinate plane that will never intersect. These are an example of parallel lines. As long as they would keep going forever, right, and these lines keep going on forever, they are never going to intersect and touch each other. Okay, they have the same slope. If I count the slope of this line, I go down 1, 2, 3, over 2, down 1, 2, 3, over 2. So the slope of this line would be negative 3 over 2. And I could look at the slope of this other line here in the same coordinate plane. I go down 1, 2, 3, over 2. Down 1, 2, 3, over 2. And the slope of this line would be negative 3 over 2. Their slopes will be exactly the same. Okay? Parallel lines have slopes that are exactly the same, not close to the same, not almost the same, exactly the same slope means the lines are parallel. So we can use that in a situation like we see here. We want to write the equation of a line that passes through a point and is parallel to another line. So here we want to write an equation that's parallel to this line. So if it is parallel to that line, it's going to have the same slope. It's going to have a slope of 2. So that means we have a slope of 2. And we've got the point, negative 2 comma 11. So now to write the equation, I need the slope, which is 2, because it's parallel to this line, so it has to have the exact same slope. And I need the y-intercept, so I can solve for that. Right? I can take 11 equals 2 times negative 2 plus b. I take my y equals mx plus b, and I fill in for the y value, m, which is 2, x, which is my negative 2, plus b, and I can solve for the b. So I can simplify this. I have 11 equals negative 4 plus b, and when I add 4 to both sides here, it cancels out. I get 15 equals b. So now I have the two things I need to write the equation of the line. Y equals 2x plus 15. And that'd be the equation of a line that is parallel to this one, same slope, and I define the y-intercept that had that slope and goes through that point. Then I can write the equation of the line using the m and the b. In this next example, write an equation of a line that passes through the point 4, negative 5. Okay, that's similar so far and parallel to the line 6y plus 3x equals negative 10. Well, here I need to figure out what the slope of this line is. So I need to take that 6y plus 3x equals negative 10, and I need to solve it for y. Okay, the slope I won't know until I get into y equals mx plus b form. So I have 6y equals negative 3x minus 10. And now if I divide by 6, everything by 6, that cancels out. I get y equals negative 3 over 6x minus 10 over 6. And really, this y-intercept part really doesn't matter. Okay, this part right here doesn't do a whole lot of anything. Okay, because all I care about is the slope. To get the parallel line, I need to have the exact same slope, so I'm going to have y equals negative 1/2 x and minus 10 over 6. You could reduce it to 5 over 3. It really doesn't matter. The key here is that our slope is negative 1/2. So the slope is negative 1/2. We have to have slope that's exactly the same. And so now I can take my point and my slope, and I can solve for the b value that would go with that information. So I take a y equals mx plus b, and I can simplify this. Negative 1/2 times 4 is negative 2 plus b. And then if I add 2 to both sides, I get negative 3 equals b. And so now I've got the two things I need to write the equation of the line. I've got the slope, negative 1/2, because I had to have the exact same slope to be parallel. And I got a y-intercept of negative 3. So my equation is going to be y equals negative 1/2 x minus 3. That would be my equation of the line that goes through that point is parallel to the line. I had to get the slope by solving for a y equals mx plus b, so I know what the slope is, so I can use the exact same slope for that parallel line. Let's talk about perpendicular lines now. Okay, perpendicular lines, we see graphed here. We have a line like this one like this. They make a right angle. Perpendicular lines will form a right angle. And when we're writing equations, the slope's the part we care about. Let's look at what happens with the slope of these two lines. This line right here, we can find the slope. We can start here and go down 1, 2, 3, 4, and over 1. So down 4, over 1. So this line has a slope of -4 over 1. And if we look at the line here and find its slope, right, let's start with this point here. We can go up 1 and over 1, 2, 3, 4. So this line will have a slope up 1 over 4. Right? Those slopes are opposite reciprocals, so they're opposite signs. One positive, one negative. So opposite signs and reciprocals. 1/4 and then 4 over 1. So perpendicular lines will have slopes that are opposite reciprocals. So they have opposite signs, one positive, one negative, and they're reciprocals of each other. We can use that information to write equations similar to what we did with parallel lines. So for this first one, we'll write an equation that passes through point 3, 5 and is perpendicular line y equals 3/4 x minus 2. So my slope is 3/4. So perpendicular slope is going to be m equals -4 over 3. Opposite signs, so I was given 3 over 4. My perpendicular slope is going to be negative then, and it's going to be the reciprocal. Instead of 3/4, 4 over 3. Now I can write the equation to solve for b. 5 equals -4 over 3 times 3 plus b. That's 5 equals -4/3 times 3. Look at this, 3 over 1, and those would simplify to 1 and 1. So I have -4 plus b. And then I can add that 4 to both sides. And I get 9 equals b. So my equation would be y equals -4 over 3x plus 9. And that'd be the equation line perpendicular this one, so these slopes are opposite reciprocals, and we can solve for the b value and put that 9 in for the b. In this next example, we need to solve for y equals mx plus b, so that we can see what the slope would be of this line that we're given. So I have -4x on both sides, subtract 4x, because I'm trying to get the y by itself. -2y equals -4x plus 8, and then I can divide by -2. Pay attention to our signs here. Y equals -4 over -2 is a positive 2x minus 4. And the minus 4 part doesn't mean a whole lot. The part we care about here is the slope. So this is a slope of 2. So my perpendicular slope is going to be -1 over 2. Right, if we want to talk about a reciprocal, the reciprocal of 2 is like 2 over 1. So the reciprocal will be 1 over 2 and different signs. This is a positive slope. This one needs to be a negative slope. Perpendicular lines have slopes that are opposite reciprocals. -1 equals -1/2 times 6 plus b. That's -1 equals -1/2 times 6 is -3 plus b. Add 3 to both sides, and I get 2 equals b. So my equation would be y equals -1/2 x plus 2. Right, so parallel lines have slopes that are exactly the same. Perpendicular lines have slopes that are opposite reciprocals. We can use that information to help us know a slope that we can work with, and then write equations of the line like we have before, needing a slope and a y-intercept. Before we look at some more linear equations with these parallel and perpendicular slopes, a little relief, royal relief. What is the only U.S. national park in Michigan? The Royal Relief. It's a little bit of a clue. You may not know this, but it's Isle Royal. Isle Royal. This is Isle Royal right here. It's actually closer to Canada than it is to Michigan. Okay, it is part of Michigan. Isle Royal right here is the only U.S. national park in Michigan. It's an island that's 45 miles long and about 9 miles wide. There's a bunch of other little islands around, but the main island, Isle Royal, is the 4th largest lake island in the world. Sorry, the 4th largest lake island in the world. And it's actually on the National Register of Historic Places as well. So rugged terrain, it's not easy to get there. It's very primitive, but lots of great nature and wildlife. So it was established as a national park in 1940, Isle Royal, Michigan. All right, let's look at some linear equations here and determine which ones, if there are any, that are parallel or perpendicular from this list. We have 3 lines, A, B, and C. So in order to determine parallel and perpendicular, we need to find their slopes. This first line, y equals 3x plus 8, well, we've got the slope pretty straightforward there. It's given to us in y equals mx plus b form. The slope is 3. The next two, we're going to do some work to get the y by itself. So in this problem, we're going to subtract 9x to get this equation, solve for y. So I cancel out. I have 3y equals negative 9x plus 18. And then I can divide by 3 on both sides, everything there. And I get y equals negative 3x plus 6. So this has a slope of negative 3. And then we'll go to line C, and we're going to get the y by itself by adding 4x to both sides to start here. So we're going to add 4x to both sides of the equation. We have negative 12y equals 4x plus 24. And then if I divide everything by negative 12, and we want to pay attention to these signs, right? Paying attention to the signs is important as we write these out. Negative 1/3 x. 4 over 12 will be 1/3, and then minus 2. So this is a slope of negative 1/3. So let's see if any of these are parallel. To be parallel, I have to have the exact same slope. So 3 and negative 3, not the exact same slope. One's a positive, one's a negative. We need them to be the exact same. And then we have negative 1/3. So none of these are the same slope. Okay? Perpendicular lines have slopes that are opposite reciprocals. So let's see if any of these are opposite reciprocals. Well, negative 3 and 1/3, those are reciprocals, but they're both the same sign. So line A and C, however, are perpendicular. Line A and C are perpendicular because they have slopes that are opposite reciprocals. Right? One's 3 and one is negative 1/3. So lines A and C are perpendicular with those slopes. All right. So remember, parallel lines, exact same slope, perpendicular lines, opposite reciprocals. And now let's look at a little application of what we've been looking at here. So writing linear equations, we'll see where it ties in with the parallel and perpendicular part. But first, let's see here the two different situations. This recreation center charges a membership fee different for residents and non-residents. Okay? And we're going to write an equation for these situations. So for the resident, the total cost, okay, it's $19 per month, right? Monthly cost of $19, no matter whether you're a resident or non-resident. So that's our recurring amount. That's the $19 per month, right? So that's our slope, 19m. Plus, for the resident, the $29 fee, okay? A membership fee of $29 for residents. For non-residents, we're going to have the total cost of $19 per month plus $109 because they're paying $109 for non-residents. Okay, so $19 per month plus the $29 paid up front, $19 per month plus the $109 paid up front. So those would be equations we could write. They would give us a total cost for resident and a non-resident. Right? So that's write the equations part. We wrote a y equals mx plus b, and using c and m, that's fine. You can use different letters, right? C for cost and m for number of months. Right? If you write y equals mx plus b and you want to use y and x, that's fine. Just define the variables so we know what they're representing. Right? Now let's do the how are these functions related. So let's look at them. If we have these two equations, we can see 19 and 19 for the slope. The rate of change is $19 every month. So these would be parallel to each other. How are they related? They're parallel because they have the exact same slope. Right? So after 10 months, the total difference in cost will be the same as it was up front, the $80 difference. If they're members for 100 months, the total difference is going to be that $80 because the 19 they're paying every month is going to be the same. They're never going to get closer or further away. The rate of change is going to stay the same and keep them parallel to each other, never intersecting, okay, always staying that $80 difference. Right? So these are parallel with the exact same slope, or in this case, rate of change, right? The rate at which they're paying per month. So parallel lines, exact same slope. Perpendicular lines, slopes that are opposite reciprocals. And we can use that information to help us determining parallel and perpendicular, to help us writing equations as well for those linear situations where we have parallel and perpendicular lines.